40 years ago, humanity took a daring leap into the unknown. In 1977, NASA launched two tiny spacecraft, Voyager 1 and Voyager 2, not just to explore our solar system, but to carry a piece of our soul to the stars. These modest machines, no bigger than a car, embarked on a journey so bold it left scientists speechless. What they discovered out there among the giants of Jupiter, the rings of Saturn, and the edge of our cosmic neighborhood changed how we see the universe and our place in it. But the story of Voyager isn't just about planets or data. It's about a message, a golden record etched with the sounds of Earth, a baby's laugh, Beethoven's symphonies, the rustle of wind, and a greeting in 55 languages. It's humanity's handshake to the cosmos, a whisper to anyone or anything listening among the stars. What secrets did Voyager uncover at the edge of our solar system? Could its discoveries hint at life beyond Earth? And what would it mean if, one day, an alien civilization finds that golden record and hears our voice? This is the story of Voyager, a tale of exploration, courage, and a dream to touch the infinite. Join Zeebo as we follow these cosmic wanderers to the edge of the unknown. In the summer of 1977, humanity stood at the edge of a dream. Two small spacecraft, Voyager 1 and Voyager 2, no larger than a compact car, lifted off from Cape Canaveral, Florida, carrying the hopes of a species eager to touch the stars. Launched just weeks apart, these twin explorers were tasked with a mission that seemed almost impossible for their time: to explore the outer giants of our solar system, Jupiter, Saturn, Uranus, and Neptune, and then venture beyond, into the uncharted realms of interstellar space. What they discovered would rewrite textbooks, challenge our understanding of the cosmos, and cement their legacy as humanity's farthest-reaching emissaries. This is the story of Voyager's epic journey, a saga of courage, ingenuity, and the relentless pursuit of the unknown. Let's set the stage. The 1970s were a time of bold ambition in space exploration. The Apollo missions had landed humans on the moon, but the outer solar system remained a mystery, known only through blurry telescope images. Jupiter, with its massive storms, and Saturn, with its iconic rings, were tantalizing targets, but their distance hundreds of millions of kilometers away made them daunting. Voyager 1 and 2 were designed to seize a rare cosmic opportunity, a once-in-176 years alignment of the outer planets, allowing the spacecraft to use their gravity like slingshots to hop from one world to the next. This grand tour was a feat of engineering and planning, a testament to NASA's vision to push beyond the familiar. Voyager 1 launched on September 5, 1977, followed by Voyager 2 on August 20th. Each carried a suite of instruments: cameras, spectrometers, magnetometers, and cosmic ray detectors powered by a small nuclear generator, a radioisotope thermoelectric generator (RTG), that could keep them running for decades. These weren't just machines, they were time capsules, built to withstand the harsh radiation of Jupiter, the frigid cold of deep space, and the test of time itself. Their creators at NASA's Jet Propulsion Laboratory (JPL) knew they were sending these probes not just to explore planets, but to carry humanity's story into the cosmos. The first stop was Jupiter, the solar system's colossus. In 1979, Voyager 1 and 2 swept past the gas giant, revealing a world more dynamic than anyone imagined. Voyager's cameras captured Jupiter's turbulent atmosphere, a kaleidoscope of reds, oranges, and whites, driven by winds faster than any hurricane on Earth. They discovered that Io, one of Jupiter's moons, was a volcanic hellscape, its surface scarred by eruptions powered by tidal forces from Jupiter's gravity. This was a shock scientists had expected: dead, icy moons, not worlds alive with geological fury. Voyager also revealed Europa, a moon cloaked in ice, hiding what we now suspect is a vast subsurface ocean, a potential cradle for alien life. These discoveries weren't just data points, they were a wake-up call, showing that the outer solar system was far more vibrant and complex than we dared to dream. Next came Saturn, the ring jewel of the solar system. In 1980 and 1981, the Voyagers unveiled its intricate rings, thousands of thin bands made of ice and rock, sculpted by gravity into patterns of breathtaking beauty. Voyager 2's flyby of Titan, Saturn's largest moon, revealed a world shrouded in a thick atmosphere, richer in nitrogen than Earth's, with hints of methane lakes and organic compounds. These findings sparked questions: could Titan host exotic forms of life? thriving in conditions alien to us. Voyager's images of Saturn's rings and moons were so stunning they became cultural icons, inspiring generations of scientists, artists, and dreamers. Voyager 2 went further, venturing where no spacecraft had gone before. In 1986, it reached Uranus, a pale blue giant tilted on its side, likely from a cataclysmic collision long ago. Voyager revealed a quiet world, its atmosphere eerily calm compared to Jupiter's storms, but its moons were a surprise cratered, cracked, and geologically diverse. Miranda, one of Uranus's moons, looked like a cosmic patchwork, its surface a jumble of cliffs and canyons, as if stitched together by a mad cosmic tailor. 3 years later, in 1989, Voyager 2 reached Neptune, the farthest planet in its tour. Neptune stunned scientists with its fierce winds faster than any planet's, and its moon Triton, which spewed geysers of nitrogen, hinting at a subsurface ocean. These discoveries painted the outer solar system as a realm of endless surprises, each world a puzzle piece in the cosmic story. But Voyager's mission didn't end with the planets. Their true legacy began when they left the familiar behind, heading toward the edge of the solar system, a boundary known as the heliopause. To understand this, let's dive into the science. The Sun, our star, emits a constant stream of charged particles called the solar wind, a bubble of plasma that envelops the planets in a protective cocoon called the heliosphere. The heliopause is where this solar wind meets the interstellar medium, the thin soup of gas, dust, and cosmic rays that fills the space between stars. Think of it as the border of our solar system's influence, a cosmic shoreline where the sun's reach fades and the galaxy's vastness takes over. Crossing the heliopause was no small feat. Voyager 1 reached this boundary in August 2012, after 35 years of travel, becoming the first human-made object to enter interstellar space. Voyager 2 followed in November 2018. Visuals, a Canva-generated graphic of the heliopause, a shimmering wall of light where solar and interstellar particles collide, with Voyager's tiny silhouette piercing through. At the heliopause, the spacecraft detected a sharp drop in solar wind particles and a rise in cosmic rays, high-energy particles from distant stars and supernovae. This wasn't just a technical milestone, it was a moment of cosmic significance. Voyager had left the sun's embrace, stepping into the galaxy itself, carrying humanity's flag into a realm no one had ever touched. The science of the heliopause is as fascinating as it is complex. The heliosphere isn't a perfect sphere, it's shaped like a comet, with a rounded nose facing the direction of the sun's motion through the galaxy and a long tail stretching behind. The heliopause is dynamic, pulsating as the sun's activity waxes and wanes over its 11-year cycle. Voyager's instruments revealed at this boundary is turbulent, filled with magnetic bubbles and plasma waves, like a stormy sea separating two worlds. These findings challenged earlier models, which assumed a sharp, clean edge. Instead, the heliopause is a chaotic frontier, a place where the sun's influence battles the galaxy's raw energy. Visuals, a dynamic Canva animation of swirling plasma and magnetic fields at the heliopause, with Voyager's data graphs overlaid to show spikes in cosmic rays. What makes Voyager's journey so remarkable is its endurance. Built with 1970s technology, computers less powerful than a modern smartphone, these spacecraft have operated for nearly half a century, surviving radiation, micrometeoroids, and the cold of deep space. Their nuclear power sources, decaying over time, still send faint signals back to Earth, traveling over 24 billion kilometers for Voyager 1 and 20 billion for Voyager 2. Visuals, NASA footage of JPL's Deep Space Network, giant radio dishes pointed at the sky, capturing Voyager's whispers. Each signal takes over 22 hours to reach us, a testament to the vastness of space and the tenacity of human ingenuity. Even in 2025, NASA engineers at JPL continue to receive data, though the signals grow weaker as the RTGs fade. Expected to last only a few more years, Voyager's discoveries didn't just map planets, they reshaped our view of the cosmos. Jupiter's volcanic moons hinted at alien oceans. Saturn's rings revealed the delicate dance of gravity. Uranus and Neptune showed that even the farthest worlds hold secrets. But the heliopause crossing was the true climax, a moment when humanity stepped beyond its cradle. What did Voyager find in the interstellar void? Was it a lifeless expanse? Or does it hold clues to the galaxy's deeper mysteries? And what happens when these tiny probes, carrying humanity's golden message, drift forever among the stars? This journey raises profound questions. If Voyager's data hints at the nature of interstellar space, could it also point to signs of life or even alien technology beyond our solar system? What would it mean if another civilization, light years away, intercepts Voyager's signal, or finds its golden record? Are we shouting into the void, or is someone out there listening? As we move to the next chapter, we'll explore the golden record, humanity's cosmic greeting card, and what it says about our hopes, our fears, and our place in the universe. When Voyager 1 and 2 left Earth in 1977, they carried more than cameras and scientific instruments. They carried a piece of humanity's heart. Bolted to each spacecraft is a golden record, a 12-inch disc plated in gold, etched with sounds, images, and greetings from our world. This golden record is no ordinary artifact. It's a time capsule, a cosmic postcard, a message to the stars. It's humanity's bold declaration: we are here, and this is who we are. Designed to survive 1 billion years in the harsh void of space, the record is our handshake to the cosmos, a hope that somewhere, someday, an alien civilization might find it and hear our voice. Like the starships in Star Trek, Voyager is our ambassador, carrying a message of peace, curiosity, and unity to the farthest reaches of the galaxy. But what exactly did we send, and why? Let's dive into the story of the golden record, a testament to our dreams, our diversity, and our longing to connect with the unknown. The idea for the golden record was born in the optimistic spirit of the 1970s, a time when humanity was reaching for the stars while grappling with its own complexities on Earth. Led by astronomer Carl Sagan, a team of scientists, artists, and visionaries at NASA set out to create a message that would represent all of humanity, not just one nation, culture, or era. The record was a response to a profound question: if an alien species found Voyager, what would we want them to know about us? How do you distill the essence of a planet with billions of people, countless languages, and a history spanning millennia into a single disc? The answer was a masterpiece of creativity and collaboration, a snapshot of Earth's soul crafted with care and hope. The golden record contains 3 types of content: sounds, images, and music, each chosen to tell a story of who we are. The sounds include the natural symphony of Earth, crashing ocean waves, howling winds, the chatter of birds, and the haunting songs of humpback whales. There are human sounds, to a baby's laugh, a lover's kiss, the clatter of footsteps in a village, and greetings in 55 languages, from ancient Akkadian to modern Mandarin. These voices say, hello, peace, and we wish you well, a chorus of humanity reaching across the stars. The record even includes a message from then UN Secretary General Kurt Waldheim, offering a formal greeting from Earth's global community. The music is perhaps the record's most universal language. The team selected 27 tracks, spanning cultures and eras: Beethoven's soaring symphonies, Bach's intricate fugues, Mozart's delicate melodies, and folk songs from Senegal, Peru, and India. There's the bluesy twang of Blind Willie Johnson, the rhythmic beats of Aboriginal music, and even rock and roll with Chuck Berry's Johnny B. Good. Why music? Because it transcends language, carrying emotion and meaning that might resonate with beings we can't imagine. Imagine an alien civilization, light years away, hearing the soulful wail of a blues guitar or the delicate plucking of a Chinese guzheng. Would they feel what we feel, Joe? Longing, hope. The images 118 in total are encoded as analog signals on the record, a visual gallery of Earth's diversity. There are pictures of mountains, oceans, and forests, showcasing Earth's natural beauty. There are humans in action, dancing, working, playing, eating, capturing the rhythm of daily life. Scientific diagrams explain our biology, our solar system, and even the structure of DNA, offering a glimpse of our curiosity and knowledge. One image shows a mother nursing her child, a universal symbol of care and connection. Another depicts the Great Wall of China, a testament to human ambition. Together, these images are a mosaic of our world, designed to speak to minds that might see the universe in ways we can't fathom. The record's design is itself a marvel, made of copper and coated in gold to resist corrosion. The record is built to last 1 billion years in the vacuum of space. Its aluminum cover includes a stylus and instructions etched in symbols for playing the record, along with a map pinpointing Earth's location using pulsars, the universe's natural lighthouses. A small sample of uranium-238, with its predictable, radioactive decay, acts as a cosmic clock, allowing finders to calculate when a record was made. This attention to detail reflects humanity's hope that someone, or something, will not only find the record but understand it. Now, let's connect this to Star Trek, a cultural touchstone that captures humanity's dreams of exploration. In Star Trek, starships like the Enterprise carry crews on missions to seek out new life and new civilizations. The Voyager spacecraft are our real-world equivalents, lone emissaries venturing into the unknown, bearing a message of peace. Like Captain Kirk or Spock, Voyager speaks for humanity, not as conquerors, but as curious explorers, eager to connect with others. The golden record is our version of the Vulcan greeting. Live long and prosper, a gesture of goodwill to any civilization that might intercept it. This parallel isn't just poetic, it's a reminder that science fiction often inspires science fact, pushing us to dream bigger and reach farther. But why send a message at all? The odds of an alien civilization finding Voyager are vanishingly small. The spacecraft are drifting through the Milky Way at about 17 kilometers per second, a snail's pace in cosmic terms. It will take Voyager 1 about 40,000 years to reach the vicinity of the nearest star, AC plus 79 3888, and even then, it's unlikely to pass close enough to be noticed. The Milky Way is vast, with 100 billion stars and countless planets, making the golden record a needle in a cosmic haystack. Yet, Carl Sagan and his team saw it not as a practical outreach, but as a profound act of hope. The record is as much for us as it is for aliens, a mirror reflecting who we are, what we value, and what we aspire to be. This act of hope carries deep philosophical weight. The golden record forces us to ask, what does it mean to be human? By choosing sounds of laughter, music of joy, and images of connection, we present ourselves as a species that loves, creates, and dreams. But the record also includes sounds of struggle, thunder, earthquakes, even the roar of a jet engine acknowledging our imperfections. It's an honest portrait, showing both our beauty and our flaws. If an alien civilization finds it, will they see us as kindred spirits, curious explorers like them? Or will they see a young, fragile species, still learning to navigate its own world? The golden record also raises questions about communication. How do you speak to a species that might not have ears, eyes, or even a concept of sound? The record assumes a universal language, music, math, imagery, but what if aliens perceive reality differently? Perhaps they see in radio waves or hear in gravitational ripples. The record is a gamble, a leap of faith that intelligence, wherever it exists, shares a spark of curiosity. And if they do find it, what will they think? Will Beethoven's notes move them? Will a child's laugh puzzle them? Will they understand the math of DNA? Or will our images of Earth seem as alien to them as their world would to us? This brings us to the record's legacy. As Voyager 1 and to sail through interstellar space, they carry this message into eternity. Even after their power runs out, likely by 2030, when their RTGs can no longer transmit, they'll continue drifting, silent ambassadors of a species that dared to dream. The golden record is a symbol of our optimism, a belief that we're not alone and that connection is possible. It's a reminder that exploration isn't just about discovering new worlds, but about sharing who we are with the cosmos. When Voyager 1 and to cross the heliopause, the boundary where the sun's influence fades and the galaxy's vastness begins, they didn't just leave our solar system. They stepped into the unknown, carrying humanity's curiosity into interstellar space. What they found there wasn't a lifeless void but a dynamic, turbulent frontier, alive with plasma, magnetic fields, and cosmic rays that challenge everything we thought we knew about the universe. These tiny probes, launched in 1977 with technology now considered ancient, sent back data that shocked scientists and reshaped our understanding of the cosmos. From mysterious plasma waves to unexpected radiation patterns, Voyager's discoveries in interstellar space are rewriting the rules of astrophysics and raising tantalizing questions about what else might be out there. Let's dive into the revelations that made the world gasp and explore what they mean for our search for the unknown. To set the stage, let's revisit the heliopause, the cosmic shoreline where Voyager's journey took a historic turn. The sun emits a stream of charged particles called the solar wind, creating a protective bubble around the solar system known as the heliosphere. The heliopause is where this bubble meets the interstellar medium, a thin soup of gas, dust, and high-energy particles from distant stars and supernovae. Scientists once imagined this boundary as a clean divide, like a wall separating our solar system from the galaxy. But Voyager revealed something far more complex, a turbulent, chaotic region where solar and interstellar forces collide, creating a cosmic storm of plasma and magnetic fields. Voyager 1 crossed the heliopause in August 2012, at a distance of about 18 billion kilometers from Earth, becoming the first human-made object to enter interstellar space. Voyager 2 followed in November 2018, at roughly 16 billion kilometers. The spacecraft detected a sharp drop in solar wind particles and a surge in cosmic rays, high-energy protons and atomic nuclei accelerated by distant cosmic events like supernovae. This transition wasn't smooth. It was like sailing from a calm harbor into a raging sea. Voyager's instruments, though aging, captured data showing unexpected fluctuations in magnetic fields and plasma density, revealing that interstellar space is far from empty. It's a dynamic, ever-changing realm. One of the most shocking discoveries was the nature of the interstellar medium itself. Scientists expected it to be a sparse, uniform void, but Voyager found it teeming with activity. The probes detected plasma waves, oscillations in the charged particles that fill interstellar space, driven by interactions between the heliosphere and the galaxy's magnetic field. These waves, detected by Voyager 2's plasma wave subsystem, were like ripples in a cosmic ocean, revealing a medium far more turbulent than predicted. The data suggested that the interstellar medium is threaded with magnetic fields, twisted and knotted by the galaxy's complex dynamics, influencing everything from star formation to cosmic ray propagation. Another surprise was the termination shock, a region just inside the heliopause where the solar wing slows abruptly, compressing into a turbulent barrier. Voyager 1 crossed this shock in 2004, followed by Voyager 2 in 2007, revealing a region packed with high-energy particles and magnetic bubbles. These findings appended models of the heliosphere, showing it's not a simple bubble, but a dynamic system, pulsating with the Sun's 11-year activity cycle. Determination shock and heliopause together form a complex frontier, where the Sun's influence battles the galaxy's raw energy, creating conditions unlike anything in our solar system. But the discoveries didn't stop there. Voyager's data on cosmic rays, high-energy particles from distant stars and explosions revealed a universe more violent and energetic than expected. These particles, traveling near the speed of light, carry clues about the galaxy's history, from supernovae to neutron stars. Voyager found that cosmic ray intensity increased sharply beyond the heliopause, confirming that the heliosphere shields our solar system from much of this radiation. This has profound implications. Earth's atmosphere and magnetic field protect us from these rays, but in interstellar space, life would need extraordinary adaptations to survive such a barrage. Could alien organisms thrive in this high-energy environment? Or might advanced civilizations use cosmic rays as a power source, much like we dream of harnessing black holes? In 2025, Voyager 1 signals continue to captivate scientists, though challenges have emerged. In early 2024, Voyager 1 sent erratic signals, raising fears that its aging systems were failing. NASA's Jet Propulsion Laboratory (JPL) worked tirelessly, using the Deep Space Network's giant radio dishes to decode faint transmissions. By mid-2024, engineers confirmed that Voyager 1 was still transmitting valuable data, including measurements of interstellar plasma and magnetic fields. These signals, traveling over 24 billion kilometers and taking 22 hours to reach Earth, are a testament to the spacecraft's resilience and humanity's determination to listen to the cosmos. One of the most intriguing findings came from Voyager 2's plasma wave subsystem, which detected persistent plasma oscillations in interstellar space. These oscillations, detected as recently as 2023, suggest that the interstellar medium is filled with low-frequency waves, possibly triggered by shocks from distant supernovae or interactions with the heliosphere. This discovery challenges our understanding of interstellar dynamics, hinting at unseen processes shaping the galaxy. Could these waves be natural, or might they carry artificial signals, perhaps from alien technology manipulating plasma for communication or energy? While speculative, This possibility excites scientists searching for signs of extraterrestrial intelligence. These discoveries have transformed our view of the universe. The interstellar medium isn't a static void but a dynamic ecosystem, filled with particles, waves, and fields that connect our solar system to the broader galaxy. Voyager's data suggests that the heliopause is a porous boundary, leaking solar particles into interstellar space and allowing galactic material to seep in. This interplay could influence star formation, planetary atmospheres, and even the conditions for life across the galaxy. It's as if Voyager has opened a window, letting us peer into the galaxy's inner workings for the first time. The implications are profound. Voyager's findings challenge the idea that interstellar space is a barren wasteland. Instead, it's a vibrant, complex environment, alive with energy and possibility. This raises questions about life beyond our solar system. If the interstellar medium is so dynamic, could it support exotic forms of life, perhaps plasma-based organisms thriving in magnetic fields, or microbes hitching rides on cosmic dust? Or might advanced civilizations harness these energies, using plasma waves or cosmic rays to power their technology? Voyager's data doesn't answer these questions, but it plants the seeds, urging us to look deeper. For astronomers, Voyager's discoveries are a goldmine. The probe's measurements of magnetic fields, plasma density, and cosmic rays are helping refine models of the galaxy's structure, from its magnetic topology to its particle flows. These insights inform missions like the James Webb Space Telescope, which studies distant stars, and future interstellar probes, like those proposed for the Breakthrough Starshot initiative. Voyager has shown that the galaxy is not just a collection of stars, but a living, breathing system, connected by forces we're only beginning to understand. For nearly half a century, Voyager 1 and Voyager 2 have carried humanity's dreams beyond the edge of our solar system, venturing farther than any creation in our history. These tiny probes, launched in 1977 with technology now dwarfed by a smartphone, have explored the storms of Jupiter, the rings of Saturn, the icy mysteries of Uranus and Neptune, and the turbulent frontier of the heliopause. They've sent back data that stun scientists, revealing a universe alive with plasma waves, cosmic rays, and magnetic fields. But beyond the numbers and images, Voyager carries something deeper, a golden record, etched with the sounds, sights, and spirit of Earth, a message to the cosmos that says, we exist, and we are curious. As we stand in 2025, with Voyager's signals growing fainter, it's time to reflect. What does this journey mean for humanity? These spacecraft, powered by nuclear generators the size of a coffee can, have traveled over 24 billion kilometers. Their signals taking 22 hours to reach Earth. They've revealed Jupiter's volcanic moons, like Io's fiery eruptions, and Europa's hidden oceans, hinting at places where life might exist. They've shown Saturn's rings as delicate bands of ice, sculpted by gravity's dance, and Titan's methane-rich atmosphere, a world that might harbor exotic chemistry. Uranus and Neptune, once distant blurs, became vibrant worlds with wines, rings, and geologically active moons. And beyond the planets, Voyager pierced the heliopause, entering interstellar space and uncovering a dynamic realm of plasma and cosmic rays that reshaped our understanding of the galaxy. But Voyager's legacy is more than scientific data. It's a testament to human ambition, built with 1970s technology computers, with less memory, and a digital watch. These probes have endured radiation, micrometeoroids, and the cold of deep space for nearly 50 years. Their radioisotope thermoelectric generators, RTGs, are fading, and by 2030, their signals may fall silent, leaving them to drift as silent ambassadors. Yet, even in silence, they'll carry the golden recur, a golden disk that could outlast Earth itself, preserved in the vacuum of space for a billion years. This durability reflects humanity's audacity. We built machines to outlive us, to speak for us when we're gone, to tell the universe our story. The golden recur, as we explore Infant 3, is humanity's cosmic calling card. It holds the laughter of children, the music of Beethoven and Chuck Berry, the songs of whales, and greetings in 55 languages. It's a snapshot of who we are, our joys, our struggles, our diversity, sent to an audience we may never meet. This act of hope, led by Carl Sagan and his team, mirrors the spirit of Star Trek, a belief that exploration is about connection, not conquest. Like the Enterprise seeking new life, Voyager carries our voice into the void, a gesture of peace to any civilization that might find it. The heliopause, where solar winds meet the interstellar medium, is a turbulent frontier, alive with plasma oscillations and magnetic fields. These findings challenge our view of the galaxy as a static void, showing it's a dynamic ecosystem shaped by forces we're only beginning to understand. The cosmic rays detected by Voyager high-energy particles from supernovae and neutron stars hint at a violent, energetic galaxy, yet one that might support exotic life or advanced technology. Could these plasma waves carry signals from alien civilizations? Could the magnetic fields hide structures built by cosmic engineers? Voyager's data doesn't confirm these possibilities, but it opens the door, urging us to keep searching. This journey forces us to confront our place in the cosmos. Voyager has shown that our solar system is just a speck in the Milky Way, a galaxy with 100 billion stars and countless worlds. The golden recur, drifting through this vastness, is a reminder of our smallness but also our boldness. We dared to send a message to the stars, knowing the odds of it being found are slim. Yet, that act of daring defines us. It's the same spirit that drove us to walk on the moon, to build telescopes like the James Webb, to dream of colonizing Mars. Voyager is proof that humanity, for all its flaws, is capable of reaching beyond its grasp. What if an alien civilization finds the golden recur? Picture them listening to Beethoven's Fifth or a Navajo chant, seeing images of our oceans and cities. Would they understand our laughter, our music, our longing? Would they see us as kindred explorers or as a young species, barely stepping into the cosmic arena? The record's greetings, in 55 languages, are a plea for connection, but they also raise a question. What would we say if we could send another message today? In 2025, with our world facing challenges, climate change, division, uncertainty, what new sounds, images, or words would we choose to represent us? Would we send messages of hope, warnings of our mistakes, or a call for unity? Voyager's journey also challenges us to look forward. The probe's fading signals, expected to cease by 2030, mark the end of an era, but they inspire the next. Future missions, like the Breakthrough Starshot Initiative or NASA's Interstellar probe, aim to follow Voyager's path, reaching nearby stars in decades rather than millennia. Technologies like fusion drives or laser-propelled sails could make interstellar travel a reality, letting us explore the worlds Voyager only glimpsed from afar. The James Webb Telescope, scanning distant exoplanets, builds on Voyager's legacy, searching for signs of life or technology in the galaxy's depths. Each step brings us closer to answering the ultimate question: are we alone? This question ties to the Fermi paradox. If the universe is so vast, why haven't we heard from anyone? Voyager's data from interstellar space plasma waves, cosmic rays, magnetic fields hints that the galaxy is a complex, energetic place. Perhaps advanced civilizations are out there, but their signals are encoded in ways we can't yet detect, like gravitational waves or modulated plasma. Or maybe they've found the golden recur and are listening, deciding whether to respond. Voyager's silence, as its power fades, mirrors the cosmic silence we hear, but silence doesn't mean absence. It might mean we're not yet ready to understand the conversation. Voyager's legacy is a call to action for humanity. It reminds us to keep exploring, to keep asking questions, to keep dreaming. The probes show what we can achieve when we work together: scientists, engineers, artists, and dreamers united by a shared vision. They challenge us to protect our planet, the only home we know, and to reach for the stars with humility and courage. Whether or not aliens find the golden recur, Voyager has already taught us something profound. Our curiosity, our creativity, and our hope are what make us human. So, here's the question for you. If you could send a message to the stars, what would it be? Would you share a song that moves you, a story of Earth's beauty, or a warning about our fragility? Would you ask for help, offer friendship, or simply say, "We're here"? Drop your thoughts in the comments below, and let's start a conversation about our place in the cosmos. Hit subscribe, join us on this journey, and let's keep exploring the mysteries of the universe together. This is Zeebo, signing off until our next cosmic adventure.